Hello everybody, today we are going to talk about operators. Firstly, let's start this topic from what are operators? As the name suggests, operator is something that can operate. So it means that it can perform, work on something. In programming world, operators are used to work on, for example, variables, expressions. In this lesson, we'll learn about arithmetic and assignment operators. So let's create two variables, int a equals 10 and int b equals 5. And now let's send to the console output a plus b, and let's send a line at the end, and this is called addition operation. And now let's compile it, and as we can see, our result is 15, so operator operated, worked on two variables, and we have got now one result, right? Which we can send to the output or assign to another variable. Okay. We have got other operators like the minus operator, which is subtraction operation. We have something like multiplication operator, and it is multiplication. Now let's talk about the division operator, and let's compile it. As you can see, our results are right. They are all good. But as you can see, when we divide 10 by 5, we have the result 2, which is right. But now let's change b to 4. And you are probably expecting that the result will be 2.5, right? 10 divided by 4. Let's see. As you can see, our result is 2, not 2.5. Why it's not 2.5? Because when we divide two integer numbers, you see that variables are integers, right? Our result will always be integer, always. The part after the point, which is in our situation 5, is being removed. Math rounding is not working here. So if you had, for example, 2.6, the result would not be equal 3, but it would be again 2. Okay. But what if we want to have a real number in the result? One of our variable must be then double or float. It doesn't matter which one. So let's do it. For example, that guy. Let's see. As you can see, we have now 2.5. It's okay. Now let's, for example, that guy, make it double. And as you can see, it's working. Of course, both can be double and they do work. For example. Okay. Let's back to the integer. And now let's talk about modulo operation, which is later really very useful, but it might be a bit confusing at start. When we use modulo operation, which is percent sign in the C++ language, on two numbers, for example 10 modulo 4, the result is 2. Now why? 2 in our situation is called remainder, and the remainder is amount left over after the division of two integers, okay? So when we look at this operation, we should think like that. How many times can 4 be located, stored in 10? The answer is 2, right? Because 2 multiplied by 4 means 8. And now, what amount is left over after the division of two integers? It is 10 minus 8, which is 2, right? Okay, now let's check the next example. For example, 1 modulo 5 is 1. Why? How many times can 5 be stored located in 1? The answer is 0, because 5 is greater than 1. Okay, so 0 multiplied by 5 equals what? 0. And now what amount is left over after the division of two integers? It is 1 minus 0, which is just 1, right? And it works. Okay. You should train it a bit. You can train it by just sending it to the console output, for example, 10 modulo 4, right? Let's compile it. As you can see, we have 2 there. A modulo B. Okay. It works fine. Train a bit because it's kinda important to understand it later. It's one of the operators that is really used a lot. Okay, fine. Now let's talk about incrementation, decrementation, and assignment operations. Incrementation and decrementation. Okay, incrementation means increasing current value by 1. Increase by 1, right? And decrementation means decreasing current value by 1. So it decrease by 1. Operations like that are so frequent that they have special operators that let us write them faster. And normally, if we want to increase current value by 1, so to increment something, we have to write something like, for example, int c equals 1. And now, when we do something like c equals c plus 1, and then we will send it to the console output. As you can see, we have now there 2 at the end, right? We can get all the things to the comment, so it won't confuse us anymore. As you can see, 2 is here. And how it works. That thing here means something like that. Take the value that is stored in variable c, which is 1, add to it 1, and then after summing that, right, assign the result to the variable named c. So c will be 2 now. Okay. Of course, that 1 can be anything here, like 10, and it works. But we are right now talking about incrementation, decrementation, okay? So we'll just increase and decrease values by 1. We can do that thing here a bit faster using assignment operator like that. C plus equals 1, which is the same, it is the same as c equals c plus 1. It's the same, okay? And of course that number here can be changed to another number or maybe variable. And there are many more operators like that. For example, division equals, minus equals, modulo equals, multiplication equals. Well, almost all operators have that shorter notation notation, okay? And let's compile it. Let's see if it's working. As you can see, everything works fine. And now, finally, let's talk about incrementation using increment operator. Okay, let's comment that thing here. And now int d equals 1. And now let's do something like that. Cout d plus plus and line. And that plus plus here is increment operator. Okay. And let's compile it. As you can see, well, still our d is 1, but is that true? Let's send d to the console output again. Let's do it here. Let's build and run, and now we can see that this is 2. It's not 1. But why? It's because we have just used something what is called, right, post incrementation. And post means here that plus signs are after the name of variable, and it also means that it will begin the expression, that thing here, from sending value to the output. So it will send to the output, and then it will increase the value by 1 because of the 2 plus signs. Okay. So now let's talk about pre-incrementation. So pre-incrementation. The pre-incrementation is looking like that. Now, as you can see, we have 2, 2 in both places. As you have probably noticed, plus signs here are now before the name of variable, which means that now variable will be first incremented by 1, and then value will be sent to the output. And how to remember what happens first? Just look at the notation of incrementation. If the plus signs are prefix for variable, right? Then incrementation is first. If the plus signs are postfix for variable, then incrementation is going to happen after sending value to the output. Okay, now let's talk about pre-decrementation and post-decrementation, right? So post-decrementation and pre-decrementation. Pre. And they work the same way like incrementation, but this time we are decreasing value by 1. So if I do something like that, and now I compile it, what will happen first? That guy here will be decremented by 1 first, and then the value will be sent to the output. Let's see. So it will be 0, right? Okay, we can see 0, 0. But if they do something like that, it will send to the output first 1, then it will decrease that value by 1, and then it will just send that 1. I'm sorry. It will send just that 1, and here the value will be 0, right? Okay, as you can see, everything is working fine, and that's all in the lesson. Thank you very much. Hello everybody, today we are going to talk about relational operators. What are relational operators? Well, as always, we will concentrate on the name, relational operator. It means that this operator operates on variables expressions by checking what relation is between them, right? So, if I have two variables, for example, int a equals 10, int b equals 5, and I want to see how they are related to each other. So, for example, if they are equal, I need to use relational operators. When we want to check if two variables are equal, we should do something like that. Cout A == B and add line. Two equal signs are representing equality in the C++ language. Remember that one equal sign is reserved for assigning values to variables. Remember about the difference because you might make many mistakes because of that, okay? And now I will try to compile, but as you can see, we have error here. You know, that angle brackets here are also operators, and now our compiler is confused. As in the mathematics, to solve problems like that, we should use parentheses. So I will add parentheses here, and now compiler will know what to do, and I will compile it. And as you can see, our result is 0. Why? The result of relation operation is always 0 or 1. 1 is representing, like in bool variable, true. 0 is representing false. So we've just got informed by that 0 in the console output that value of variable A is not equal to value of variable B, right? Because our result was 0, right? Okay. So we can use that 0 or 1 informations later by using something what is called conditional statements, but we'll talk about them later in other lessons. Right now, let's talk about all relational operators. So this guy is true when both variables have the same value. Now let's talk about that guy. I will copy that. We are using instead of 1 exclamation mark, and exclamation mark is just saying that it is not equal, right? So it is true when both variables do not have the same value. Let's compile it, and as you can see, it's true because 10 is not equal to B, so it's true. Okay, now let's talk about that guy, and it is true when value of variable A is greater than value of variable B. So in our situation it should be true, right? As you can see, we have 1 here, so everything is okay. Now next guy, A. So this is true when value of variable B is greater than value of variable A, right? So this should be 0. And as you can see, everything works fine. Now let's find out that guy. And when value A is greater than or equal and here is that to value of variable B. Okay, so it's okay, it should be true. If that variables were equal, it will be true also. Okay, now that guy, so B is greater than or equal to value of variable A. So it should be, in our situation, false. We can also use exclamation mark to change value from true to false. So from 1 to 0 or 0 to 1. And to do it, we should do something like that. For example, I will add exclamation mark here, and now I will say if that guy here, if that result is 0, change it to 1. If it's 1, change it to 0. So in our situation, A is not equal to B, so that guy will be true. Okay. So that notation is the same as that guy. Okay, that's all in that lesson. Thank you very much. Hello everybody. Today we are going to talk about logical operators. Why are they called logical operators? Because they work like in the math logic section. Don't worry if you don't know or do not understand that subject. I will try to explain it the easy way. Please concentrate, and if you do not understand this topic, watch this video again, because it's really important to know how the operators work. Let's create multi-line commands. Okay, and first operator that we learn in C++ is called AND operator, which is called in math conjunction. Okay, so it is used to connect something, and in the programming language it is hidden behind two ampersand signs, that signs here. And you can think about conjunction like it was a connector of two expressions. And what do I think by saying expression? I'm thinking about things like that. 7 is greater than 5, 5 is not equal 10, and well, mostly the things that we learned in the last lesson, right? Okay. And you know that expressions have results, right? As I said in previous lesson, the result is 0, which is representing false, or 1, which is representing true. And when we connect two expressions, right? Two expressions with AND operator like that, for example, we are saying that both expressions have to be true if we want the full sentence to be true. The sentence is that thing what I have just highlighted, okay? So this is the sentence. And so sentence is something like two expression connected with, for example, that conjunction here, right? Okay. Okay, so let's note that conjunction is true only if both expressions are true. Okay, and let's check it out. See out. Now I'll use the parentheses and our sentence here, right? And let's build our program. As you can see, the result is 1. Why? Is 7 greater than 5? Yes. Is 5 not equal to 10? Yes. So here I have from that expression 1. Here I have from that expression 1, right? And 1 and 1, and is that thing here. 1 and 1 is also 1, because conjunction is true only if both expressions are true. Okay? Well, for example, let's change the numbers here. Now I will say that 5 is greater than 7, which is of course not true. So here I have result as a result 0, and here I have as a result 1. So 0 and 1 should give us false, so it will be 0, right? And as you can see, everything is working fine. Let's make a table for that. So if I have, for example, expression 1, expression 2, and the result is, so 0, 0, result is 0, 0, 1, result is 0, 1, 0, result is 0, and conjunction is true only when both expressions are true. Okay. Now let's talk about logical OR operator. OR. And it is represented in C++ by two pipe signs. That signs. And in math it is called disjunction. Okay. Sometimes people call it alternative. Okay. And disjunction is working like that. Let's make a table. So, as you can see, disjunction is false only when both expressions are false. In all other situations, disjunction is, of course, true. And how to memorize it? I think if you want to memorize it, I would suggest thinking about disjunction as alternative. In real life, when we are deciding, we are trying to choose right decisions, right? And which are in programming language represented by 1, 2. So here we have only false expressions to choose. So the result is 0, right? 0, 0, and I have no choice. I have to choose 0, and okay, the result will be 0. But in other situations, as you can see, we have always at least one right decision. I have got one decision to choose, 0 or 1. Oh, okay, I will choose 1 because it's better for me, of course. I will feel better. Okay, that's why the final result is 1, 1, 1 in the places here, because we are choosing always alternative decision, which is good for us. Okay, let's try it in programming version. So I will change the guy here to alternative. So as you can see, is 5 greater than 7? No, so I have here 0. Is 5 not equal to 10? Yes, so here I have 1. So 0 or 1 is what? The result is 1, of course. I will choose the easiest alternative for me. The right decision, okay, is 1 for sure. And let's check it. Build and run. As you can see, I wasn't wrong. What if I have both expression as false? As you can see, the result is 0. So everything is working fine. Maybe let's know that this junction is false only when both expressions are false. Okay, and now it is the last operator, which is called logical negation operator, which is represented in the C++ language by exclamation mark. Okay, and it is just changing 0 to 1 or 1 to 0. So if I have, for example, that thing, the result will be 1. If I have something like that, the result will be 0. So here our result is right now 1. If I want to if I use that exclamation mark here, it should be, as you can see now, 0. So 1 was changed to 0. So we can understand that exclamation mark as our word no, right? No, not. It's not something. Okay. Probably this topic might be confusing for you, and you might be thinking like, how is it important for programming, right? I'm assuring you that in next lessons you'll notice that this thing is really important. You can create many very important things by using the knowledge in this lesson. Okay, that's all. Thank you very much. Hello everybody, today we are going to talk about Bitwise Operators. Before we start, I would like to mention that this topic is not easy for most of the programmers, so don't worry if you don't understand it. However, it's a good idea to watch it and know about existence of something like that. Okay, what are Bitwise Operators? Bitwise Operators are created to work on bits. I will remind that bit is the smallest information that can be stored in our computer, and it is represented by, let's know that, 0 and 1s, right? And the 0 or 1 can be connected. For example, 8 signs of connected bits is called byte. So for example, sequence, something like that. And if we want to operate on that 0 and 1 signs, we have to use bitwise operators. Look, every number is stored in computer by using that 0 and 1 signs. Computer notation is surprisingly very similar to our notation, which is called decimal notation. Let's remind it. For example, number 126. This number is really created of something like that. 1 multiplied by 10 raised to the power of 2 plus 2 multiplied by 10 raised to the power of 1 plus 6 multiplied by 10 raised to the power of 0. And as you can see, that thing here is equal to 100, that thing here is equal to 20, that thing here is equal to 6, because 10 raised to the power of 0 is 1, right? So 1 multiplied by 6 is 6. Okay, and you might be now like, why am I saying this? It's because if you want to change computer notation, which is called binary notation, we must do the same thing. We need to understand the changes to understand bitwise operators. For example, let's change something like 1010. This thing is something like 1 multiplied by something plus 0 multiplied by something plus 1 multiplied by something plus 0 multiplied by something. As you can see, I am writing what? Just the numbers here, right? And if you look at both, I was writing also that numbers here, as you can see. Okay, and now we need to write what? We are using here 10. Why 10? Because here is a decimal numbers. So we are right. We are counting to 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and that are 10 numbers already. We have 10 fingers, right? And that's why here is 10. In computer we have only two numbers, 0, 1. So here we will multiply by 2. Multiply by 2, multiply by 2, multiply by 2, multiply by 2. And now, as you can see, I was rising to the power of what? Look, here is the position number 1. Here is the position number 2. Here is the position number 3. So, as you can see, that numbers are decreasing. 2, 1, 0. 3, 2, 1. So this is the number of position minus 1. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Okay, so here how it should be. 2 raised to the power of 0, 1, 2, 3. Okay, so to the power of 3. 0 multiplied by 2 to the power of 2. 1 multiplied by 2 raised to the power of 1. 0 multiplied by 2 raised to the power of 0. And now that thing here is decimal number. So 1 multiplied by 2 to the raised to the power of 3 is 8, plus that thing here is going to be 4, but 4 multiplied by 0 is just 0. So 0 plus 2 multiplied by 1, so it's 2 plus 0, so 1010 is really, in our word, in decimal notation, 10. Okay. You should also notice now that when you see 0 in binary notation, you can pass it, because anything multiplied by 0 is just 0. So why do so many things? You can just remove it, right? And now it's a bit shorter. And again, you should also notice that anything multiplied by 1 is still the same number. So we should focus on which place is that number and raise 2 to the power of position minus 1. So we should just do something like that. And now it's very short, right? And let's use the thing that we have just learned about. And for example, I have 1 0 1 1 0 0, and you should think like that now. Here I have 0, so I don't need to think about that situation, because anything multiplied by 0 is 0. But normally here is hidden number 1, if 0 was 1, right? And now again number 0, so I will just pass it, but I remember that if it was 1, there will be number 2 in decimal notation. Okay, now I have here 1, and now I know that I should raise 2 to the power of position minus 1. So what position is it? 1, 2, 3. 3 minus 1 is 2. So 2 to the power, 2 raised to the power of 2. So I have 4, right? And I memorize it somewhere, or I'm just writing it here, right? And now plus 2 to the power of 3, because I have got here 1. Now I have 0, so I know that here would be 2 raised to the power of 4. Here is 2 raised to the power of 5, plus 2 raised to the power of 5. So it's what? 4 plus 8 plus 32. So it is 44. In Windows 7 we can use something like binary calculator, and now when I write here 44, as you can see, we have got here 1 0 1 1 0 0. So I was right. 44 is in our computer set as 1 0 1 1 0 0. But as you can see, also before that 1 are many zeros. Okay? Okay, now we can learn about the bitwise operators. Before we start, I'd like to mention that I'm assuming that you understand lesson about relational operators very well. Okay, let's start from making multi-line comment, and let's start from bitwise and operator, which is 1 ampersand. It works like relational operator AND, but remember, this time we are operating on bits, not on the results of expressions. Okay, we have got also bitwise OR, which is 1 pipe, and it works like relational operator OR, but this time again we are operating on bits, not on the results of expressions. We have got also bitwise operator NOT, which is tilde, and it works like relational operator negation, which is exclamation mark there, but this time again remember that we are operating on bits, not on the result of expressions. And there are 3 more operators here this time. Bitwise Exclusive OR, which is caret. Exclusive OR because it looks like that, right? It's abbreviation for exclusive OR. And this thing is also called exclusive disjunction. Exclusive means here that we cannot have more than one alternative to choose. So table for XOR is 0, 0, which gives us 0 because we don't have any right alternative to choose, right? Because we have only 0, 0, so what to choose here. 0 and 1 will give us 1 because we can choose the right alternative here, for example that guy, and 1, 0, which gives us 1 because we can choose the right alternative here too, for example that guy, and 1, 1, which gives us 0 because we cannot choose more than one alternative in exclusive OR. There can be only one right alternative at once, so it must be exclusive. Okay, it's a bit different from that guy here. Okay, we have got also something what is called bitwise left shift operator, which is 2 angle brackets pointing to the left. They are used, as the name suggests, to move bits to the left, but we'll explain it more clearly later. We have got also bitwise right shift operation, which is 2 angle brackets pointing to the right, as you can see, and they are also used, as the name suggests, to move bits to the right, and also we'll explain it more clearly later. Okay, now it's time to do some exercises. For example, cout and 10 and 2, and we want to see what will be the output. Okay, let's do something like that. Look, normally 0, 0, 0 is just 0, right? If I want to change that thing to 10, let's do something like that. Here normally is hidden 1. Here normally is hidden 2. Here normally is hidden 4. Here normally is hidden 8. So 8 plus 2 will give us 10. So I change this guy to 1, this guy to 1, and this thing is 10, right? Now I think about that 2 here, so it will be 0, 0, 1, 0. And now we have got here 10 in decimal, and here 2 in decimal notation, when I change it from binary notation, of course. Okay, and now we have just used something here, what is called AND operator. And the AND operator, bitwise AND operator, it's working like relational operator, as I said. So when conjunction is true, only when both arguments are true. So 0, 0, and this thing is 1 because we have got here true, true, and 0. So what is going to be here? It should be 2. As you can see, the result is 2. Okay, now let's try the OR bitwise operator. So operator OR is working like what? It is false only when both arguments are false. So here is true, false, true, false. So the result is, as you can see, 10. It's working well. Okay, now let's try the alternative or exclusive OR. I wanted to say, sorry. And now how it works we can see here. So here is 1, here is 0, here is also 0. So the result is what? 0 plus 0 plus 0 plus 8. As you can see, it is 8. Cool. Now let's check the negation, the not bitwise operator. For example, let's do 10 and now something like that. And now 1010 should change to 0101. And you might be thinking that the result is what? 1 plus 4 is 5. But the result is minus 11. Why? As you have noticed probably when I was running that calculator here, look how many zeros we have here. So here is so many zeros, and that many zeros are changed to 1, right? Also, and in programming, if you want to achieve the minus number, the first guy must be 1. The first number here is indicating that the number will be, as you can see, negative. And now we are decreasing it, right? Okay. Well, maybe I should have said increasing, because when we are on negative side, it's working different way. Well, never mind. Now you can see why we have got here the negative result. Okay, now let's talk about cout and that shifting guys. That guy's here, right? So, for example, I do something like that. 10 shifted one time to the left side. And what the hell is that? Look, for example, I have that guy here, right? And I am saying, hey, move to the left side. So this guy here will be moved to that place, so that guy will be 0, but the guy that was here is moving here, so 1, 0, and now 1. So right now what happened? We increased that number for sure, right? But by how much did I increase that number? We are all the time doing something like raising number to the power of 2. So 2 to the power of 0, 1 to the power of 1 is 2, 2 to the power of 2 is 4, 8, 16, right? So 16 plus 4 is 20. So the result will be 20 in decimal notation. And if I did something like that, I would have one more time that bits shifted to the left side, and we would have 40 here, because we would multiply it by again 2. So this thing means that we are multiplying by 2 raised to the power of that thing here. So this thing means that we are multiplying 10 by 2 raised to the power of 2. This time it's 2. Let's write maybe 3. Okay, to the power of 3. And so 10 multiplied by 2 to the raised to the power of 3 is what? 10 multiplied by 8, so I should have 80 here. Let's see if I'm right, if I'm not lying, and as you can see, everything is working fine. Okay, so if I am doing it another way, so that way, that we are dividing 10 by 2 raised by something. So let's divide by 2 raised to the power of 1. So I am dividing by 2, 10, so the result should be 5. This time we are moving it another way, so this thing will be changed to what? 0, 1, 0, 1. So it will be 1 plus 4, 5, right? Let's check it out. Sorry, of course, we should change that guy to the right. And now it works fine. Okay, it's 5, everything is okay. That's all in the lesson. Thank you very much.